Hello, welcome to T-Level Tactics and this video on computational thinking for Root Core 4 digital analysis of the T-Level Digital Support Services course. And in this video we're going to identify the key components of computational thinking. We'll explain the purpose of each stage in computational thinking, and we'll also apply computational thinking to solve a problem. Before we get started, T-Level Tactics videos are not endorsed or sponsored by any education institution or qualification awarding body. And these videos should not be used as a replacement to any classroom learning you might be receiving, as the discussion and practical activity with your peers and lecturer will help to expand your thinking and comprehension. Instead, these materials are best used as preparation material or as revision to reinforce your learning. These videos also cover the same content and required knowledge for Root Core 4 of the T-Level Digital Business Services course. However, they will be more contextualized towards IT support roles. So what is computational thinking? We've already looked at algorithms and what they can be used for, and we've created some simple algorithms as well. But how could we create complex algorithms like Amazon's recommendation system that we looked at? Well, this is where computational thinking can help us. Computational thinking is a problem-solving process that involves a set of skills and techniques used to analyze and solve complex problems. It uses logical reasoning and critical thinking to analyze problems, and then applies techniques from computer science to solve problems in various fields. It's used in programming, data analysis, project management, and even you could use it in some of your everyday decision-making as well. Computational thinking breaks problems down, identifies repetition, focuses on the essentials, and takes steps to implement solutions. How does it do it? There are some key components involved. There are 4 of them: decomposition, pattern recognition, abstraction, and action. Let's see how each of these components works. Each element of computational thinking serves a purpose, and each one is important in the process of building computational processes and algorithms. Decomposition is the process of breaking down a complex problem or system into smaller, more manageable components. It simplifies problem solving, focusing on one part of the problem at a time. There are 3 steps in decomposition. Step 1. Identify the overall problem and clearly define your main challenge or goal. Step 2. Break it down into sub-problems and divide it into smaller, actionable tasks or components. And step 3. Analyze each component and understand the requirements and dependencies of each of those sub-problems. Let's look at an example. Imagine you're planning to take a holiday. We can use decomposition to help us plan this. Our overall problem is, well, we need to organize a successful holiday. And we can break this down to sub-problems such as researching where we want to go, booking flights, arranging accommodation, and creating an itinerary of activities to do when we're there. Each of these tasks can then be handled individually. In project management, decomposition can help to break projects down into phases or manageable tasks. And in software development, decomposition can aid in dividing applications and code into smaller, manageable modules for easier development and testing. The next stage of computational thinking is pattern recognition, which is the process of identifying similarities, trends, and patterns within problems or datasets. And it helps in understanding complex problems by revealing underlying structures and relationships. In software development, pattern recognition can help identify where code could be used multiple times, potentially for different areas of an application. We can then separate out these elements into modules or functions that can be called on when required, helping us to reduce the amount of code in an application. And if that function needs to change, this can be done in one location rather than in multiple instances within a program. The third stage of computational thinking is abstraction, which is the process of simplifying complex systems by filtering out unnecessary details and focusing on the essential aspects. And it aims to reduce complexity and enhance understanding by highlighting key features while ignoring irrelevant information. There are some key steps in abstraction. 1. Identify the essential features and determine the most important elements of the problem or system that need to be addressed. Step 2. Filter out any unnecessary details and remove extraneous information that does not contribute to the understanding or solution of the problem. And step 3. Create a simplified model. Develop a representation, such as a diagram, flowchart, or prototype, that encapsulates the essential features. Let's see abstraction in action. Imagine you have the following in front of you: a dog, a cat, a car, and a bus. We can use abstraction to simplify each of these down. We know that both dogs and cats are animals, and that cars and buses are both vehicles. We can then identify things that all animals have or all vehicles have. For animals, this could be the number of legs they have, the noise they make, and their colour or pattern. In programming, we can then create a template to hold this information that can then be used for any animal. This could be in the form of a class, and it might look a bit like this. This bit of code creates a class called animal, and then creates some parameters that we can set, called legs, noise, and colour. This is just a template, and we can then call upon it later to create new animals following that structure. So we can use that template whenever we want. We can create a new thing based upon it, in this case, an animal. And then later on, we can call upon it and access those properties individually whenever we need them. Here's an example of us creating a cow using that class. And you can see that we type in animal. The number 4 represents the number of legs. Moo represents the sound. And brown represents its colour. Then, if we want to display those properties, we can print cow.noise, and the result will give us moo. Abstraction is just thinking about all the things in common that multiple things might have. As another example, you could think of shapes. You could count how many sides and how many angles or corners it has. These are attributes that all shapes have in common, and we can then use that as a structure to define most other shapes. The fourth stage of computational thinking is action, sometimes referred to as the algorithm stage. And the action stage is where solutions are implemented based on the previous steps we've carried out. And this is where we identify 3 different types of actions that we might want to use, or 3 different algorithms: sequences, selections, and iterations. Sequence is where we can identify the order in which processes or steps are executed. This means we can ensure that tasks are completed in the correct order for successful outcomes. For instance, in a recipe, the sequence might be to gather ingredients, mix the ingredients, bake, and then serve. They need to be carried out in that specific order to get the correct outcome. Selection is identifying when actions rely upon specific conditions being met, and what those conditions are. This allows for decision-making based on varying conditions and enabling dynamic responses. In programming, using if-else statements to determine which block of code to execute based on user input is an example of selection. And iteration is identifying processes that can repeat until certain conditions are met. This facilitates refinement and improvement of solutions through repeated testing and adjustments. We can use loops in programming to repeat a set of instructions until a specific condition is satisfied, such as processing items in a list, and we looked somewhat at that in the first video of this course. So if you're a Patreon member, head over to patreon.com/tleveltactics and download the task sheet for this video, and have a go at the first task. If you're not a member yet, head over to patreon.com/tleveltactics and have a look at all the great resources that our members get access to, including task sheets, workshop videos, and exclusive podcast editions as well. Once you've got the task sheet, open it up and spend about 30 minutes on this first task. Pause the video while you have a go, and when you're done, come back, we can move on to part 3. So let's have a go at applying these techniques to a problem. How do we employ these techniques to solve problems? Let's look at an example. In this example, we'll be looking at designing a personal budgeting app. Step 1. Decomposition. We first need to break down the problem and think about what are the main features of our application. Well, in this example, I'll use these features. We could have user registration and login, income tracking, expense tracking, budget creation and management, and reporting and analytics. Each of these could be a separate stage and task in our project. We'll also need to design a user interface for each feature, implement some back-end logic for data storage and retrieval, and set up a database to store user data in as well. Pattern recognition. At this step, we could be looking at other budgeting applications and identifying common features and user preferences such as visual graphs for expenses or alerts when we overspend. And we can also look for trends in user feedback to inform our feature prioritization. For instance, users often request the easy categorization of expenses. Step 3, abstraction, is where we can identify the essential features we need. We can create some high-level models or wireframes that outline core functionalities, such as a layout of the dashboard showing income, expenses, and budget. We can also start defining classes, those templates we mentioned before. For example, we may want to define what a transaction is and what it's made up of. And it could look a little bit like this. It could include the amount of money, the category we want to put it in, and the date where it either entered or left our account. In step 4 action, we can get into a bit more detail on the algorithms we're going to use and the functionality of the program. We'll need to use each part of the action stage: sequence, selection, and iteration. In sequence, this could be where we define the order in which a user interacts with the application and how users will get from screen to screen. For example, a user could log in, add an income, add an expense, and view a budget report. How will they get to each of those features? In selection, this is where we can identify certain features that are conditional, such as if a user exceeds their budget, we could display an alert. Or if a user's balance is negative, display the balance in red. Or if the total of transactions is not equal to current balance, than display an error message. And in iteration, now we can define what elements of the program will need to loop or continually run until a certain condition is met. For example, calculating total expenses by iterating through a list of expense transactions to continually update a user's balance, rather than them having to press a button to calculate it manually. By applying computational thinking to the project, the development process becomes structured and efficient. The project can then be split into separate elements for team members to work on, and it provides a clear framework for project members to understand their roles and contributions. The same processes can be applied to nearly any project, whether it's software development, database modeling, network design, or even a personal project of your own. So for Patreon members, head back to the task sheet and have a go at task 2, where you're going to apply these concepts of computational thinking to this example. There's a bit more guidance on the task sheet for you, and I recommend spending about 45 minutes on it. So pause the video here, have a go, and then come back when you're ready to finish things off with a couple of exam questions. So in this video, we've identified the key components of computational thinking. We've explained the purpose of each stage in computational thinking, and we've also applied computational thinking to solve a problem. Let's have a go at some exam-style questions. The first one is, define decomposition in the context of computational thinking, and provide an example of how decomposition can be applied to a real-world problem. And the second question, explain the concept of abstraction in computational thinking. And that brings us to the end of the video. In the next video, we'll be looking at design tools we can use to help us in the computational thinking process. So make sure you're subscribed at youtube.com/@tleveltactics to catch up on that video and be notified when it comes out. And if you're not a member of our Patreon yet, head over to patreon.com/tleveltactics to take a look at all the exclusive resources our members get, such as the task sheets, workshop videos, and the podcast editions as well. Thanks for watching, and see you next time.